This video is for class 9 physics, and today we shall discuss the expression for liquid pressure, which is P equals to H rho g with its proof. Okay, the pressure exerted by a liquid, as we have understood from the previous video, of density rho, right? If the density is rho at a depth h, right, then its expression becomes P equals to H rho g, where g is the acceleration due to gravity. Therefore, pressure equals to depth multiplied by density of the liquid multiplied by acceleration due to gravity, and we are supposed to prove it, right? So let us go to its proof section. So pressure exerted by a liquid column, right, where P equals to H rho g. Here P stands for pressure, H stands for height of the liquid column or depth of the liquid, rho stands for density of the liquid, whereas g stands for acceleration due to gravity. Combining all this, we shall get an expression P equals to H rho g, right? Here P equals to H rho g, where rho is the density of the liquid, as I have written here. Okay, now to prove this, let us consider a column of liquid, any liquid, it can be any liquid, right? So let its density be rho. Okay, let its density be rho, and let us take h as the height of the liquid column. In your book, one container is given, right? In your book, certain kind of container is given to you all, where this has been scooped out. So here we don't need to do this, we can do it along with the container, or we can take the cylindrical shape of the liquid column. Okay, so you can take any shape in fact. So thrust exerted, because you know pressure should be equal to pressure should be equal to thrust upon area, right? So let us try to find pressure's formula, which is P equals to H rho g, with the help of this formula. Now thrust exerted on the surface PQ, because I need to calculate thrust in order to calculate pressure, should be equals to the weight of the liquid column PQRS, weight of the liquid column PQRS, right? So now weight formula will be mass into acceleration due to gravity, that is m into g. I hope you know this, but as you all know, mass should be equals to volume into density. From the formula, density equals to mass upon volume. We have done this in class 7. So the formula of mass will be volume into density. Hence this m becomes v into rho. This m becomes v into rho, where rho is the density of the liquid taken here, where rho is the density of the liquid taken here. Okay, now coming to its next expression right here, I have written A H rho g. Now you know volume should be equals to area into height. Volume should be equals to what? Area into height. If A is the area of the liquid column here, if A is the area of the liquid column, if A is the area, if A here and A here should be same, right? If A is the area of the liquid column, then volume should be equal to this area multiplied by this height, so A into H. Hence I am getting volume equals to area into height. So V equals to AH. So replacing the value of V, right, I shall get AH rho g. AH rho g. Now pressure should be equals to thrust upon area, as you all know this. The value of thrust just now we calculated it to be AH rho g, right? So pressure exerted by this liquid column here, on this flat area, whose value is supposed to be A, will be pressure equals to thrust upon area. Just now we calculated the value of thrust, which was supposed to be AH rho g. Okay, so replacing the value of thrust in area, we shall get P equals to AH rho g upon A. So A and A can get A and A can be cancelled. This A and this A can be cancelled. Hence the remaining expression will be P equals to H rho g. This is the proof for the expression for liquid pressure. Okay, going back to the book, we have done till here. P equals to H rho G. Note, since there is atmospheric pressure above the free surface of the liquid, so to find the total pressure at a depth inside the liquid, it must also be taken into consideration. If the atmospheric pressure acting on the free surface of the liquid is P0 or P0, then total pressure in a liquid at a depth H equals to the atmospheric pressure plus the pressure due to the liquid column, which is equal to P0 plus H rho G. Let me try to explain that. Suppose we take one container, right? Suppose it contain one liquid, right? So on the surface of the liquid there will be atmospheric pressure acting. Atmospheric pressure, and at this depth here H, okay, at this point here the pressure exerted by the liquid column will be H rho G. So what is the total pressure at this point now? What is the total pressure at this point now? This whole thing due to this liquid column here, it will be the atmospheric pressure. It will be the atmospheric pressure plus this pressure, right? If the atmospheric pressure is taken as P0, okay, then the total pressure will have the expression P0 plus H rho G, right, which you have understood there in the book. So this pressure here P0 plus H rho G, that is the total pressure in a liquid at a depth H. I hope you understood this. Now coming to the next topic, which is factors affecting the pressure at a point in a given liquid. So just now the pressure had this formula, the liquid pressure, the fluid pressure had this formula, P equals to H into rho into G. So these are the three factors on which the pressure should depend. Number one, it should depend upon the depth of the point below the free surface. Number two, it should depend upon the density of the liquid. And number three, it should depend upon the acceleration due to gravity of that particular place. So at a particular place on the earth's surface, the acceleration due to gravity G is constant. Therefore the pressure at a point in a liquid is directly proportional to the depth, right, of the point below the free surface of the liquid and directly proportional to the density of the liquid. So as deeper you go inside the liquid, you start feeling more pressure, and if you are taking a liquid which is of high density, right, it can exert more pressure on the object. Okay, so however the pressure inside a liquid does not depend upon the shape and size of the vessel in which the liquid is contained, and number two, the area of surface on which it acts. So when I was deriving, I said that when I was deriving this expression, right, I said that P equals to H rho G, I said that we can take any shape or any area, right, any object, the formula should come same, P equals to H rho G. So these are the two factors on which the fluid pressure does not depend: shape and size of the vessel, and number two, the area of surface on which it acts. Okay, so I hope you understood till here, right? Thank you so much.